In this problem, we are given the magnitude of the moment caused by the force Fb about point E, but we need to determine the distance d. So we're going to set it up as if we are going to find the moment caused by Fb about point E. So we're going to calculate this, try to calculate this using the same method that we've learned so far. And obviously we will always have an unknown d in it, so we cannot fully solve for it, but we will come up with some kind of expression. And then we're going to try to calculate the magnitude of it. Again, that magnitude will also have the unknown d in it. And then we're going to set up that magnitude to be 600. So we will have one equation. We only have one unknown d, so we're confident that we can solve for that unknown. So, as I said, we start with the same way how we would try to find the moment caused by Fb about point E. That equals to a position vector cross force vector B. Force vector B is Fb is directed from point A to point B. So when we choose the position vector, we have two viable options, either position vector Ea or Eb. Obviously, there are unlimited numbers of position vector we can write, but they are not going to be convenient for us. But comparing these two position vectors, Eb obviously is simpler than Ea. So we're going to choose Ea as our position, Eb as our position vector. So when it comes to the position vector, it's like a bridge. It bridges the reference point to the force vector. So it needs to be drawn from the reference point and it lands on the force vector. So we've decided we're going to use REB, which can be determined quite easily because it only has one positive y component. The magnitude is d, so this is going to be dj in the unit of meter. What about our force vector Fb? So to determine our force vector, we do the same thing. This equals to its magnitude, which is known, 400 Newton, times the unit vector from A to B. The unit vector from A to B can be determined from the position vector, RAB. And RAB is negative 5i plus dj. Again, we don't know what d is. We keep that unknown, plus 3k. Divided by square root of negative 5 squared plus d squared plus 3 squared. So we can try to simplify this as much as we can. The denominator and the numerator both contain d in it. So the denominator is square root of 34 plus d squared. And then for the numerator, we will have first term negative 2000 I, and then plus 400d over square root of 34 plus d squared j, plus the last term is 1200 over square root of 34 plus d squared k in the unit of Newton. So now my ME equals to my position vector dj cross my force vector. I'm not going to write it again. This is a relatively easy cross product. We don't have to use the matrix. We can just use the ijk component and the right-hand rule. So j cross I equals to negative k. And so j cross I equals to negative k. J cross j equals to 0. J cross k equals to positive I. Using this information, we can determine this to be 1200 d square root of 34 plus d squared times I plus, erase this part right here, 2000 d over square root of 34 plus d squared k. So that's the moment caused by the force Fb about point E in vector form. We need to determine its magnitude. Its magnitude, if you remember, it equals to square root of its I component squared plus, or x component, plus the z component squared. Therefore, I'm going to take this whole thing to the second power. Therefore, me squared equals to 1200d squared. But the denominator is simply 34 plus d squared, plus 2000d squared, and then the denominator is 34 plus d squared. But we know what me is. Me equals to 600. Therefore, this on the right-hand side equals to 600 squared. So this also means that 1200d whole thing squared plus 2000d whole thing squared equals to, I can multiply the denominator onto the right hand side, 600 squared multiplied by 34 plus d squared. So from here, you realize that if you treat d squared as an unknown, you can solve for d squared, because it's just algebra from this point on. So we would have on the left hand side 5440000 squared. On the right hand side 1224000 plus 360000 d squared. From here we can solve for d squared to be 2.409. Therefore, d is the square root of that. We only take the positive value, obviously, because the distance has to be positive. And the answer is 1.55 in the unit of meter. So this problem, the setup is the same as the other problems, except that we need to carry over this unknown until the very last step. But eventually we will only have one equation, one unknown, and we can solve for that unknown. So sometimes the problem doesn't necessarily ask for the final force or the final moment. Sometimes you can ask for other things like distance. What you need to remember is that it's not about which unknown you need to solve for. It's about the number of unknown doesn't match the number of equations you have.